Hello class, I want to go over the review for the quiz. This is supposed to help you if you have any sort of questions, and I'm going to probably do half of the review in the first video and the second half in the second video. So let's get started. On the first one, we want to find the distance between 2 points. So I mentioned to you in class how we want to maybe graph the points, and instead of using the distance formula, use Pythagorean theorem. So I'm going to plot the points and then draw a right triangle from that. So here I've plotted the points. I'm going to draw a triangle, and it's going to be a right triangle. And from this information, I can see that it's obviously a right triangle, and the height of the triangle is 6. The width of the triangle it's going from, oh, my bad, it should be 3, -2. So let me just erase this. 3, -2. So that should be 4. And then that's 6. So you're going to use Pythagorean theorem, and it'll be 4 squared plus 6 squared equals the distance squared. So the distance will be the square root of 16 and 36, which will be root 52, which will be 2 root 13. That's choice B. Next question says that you have 2 points that are on opposite sides of a circle, and you want to find the coordinates of the center. So just between the 2 points, you want to find the midpoint between the 2 points, and that would be averaging 6 and -4, and that would be -5. And then the other coordinate would be -1, average that with 5, and that coordinate would be equal to 2. So choice D is our answer for that one. On the next question, they ask you whether or not it's a relation. Anytime you have a set of points and you have duplicated x values, I'm looking at the x values, and if I have a duplicated x value and a different y value, then the function is a relation. It can't be a function. So in this case, the only duplicated x value has the same exact y value, so that means that this can be called a function. So this relation is a function. In the next problem, they ask us to use our graphing calculator to graph this linear function. So I'm going to just bring up a picture of that function in a standard window from my graphing calculator. And here I have the function y equals 5 minus x, and if you notice, the function is going to run in these directions forever, so that implies that the domain is going to be from -infinity to +infinity, because it's going to use up all the x-axis values, and the range will be also, because it's going to use up all the y-axis values as it goes up in this direction forever and down in that direction forever. The range will be also from -infinity to infinity. In our next function, we have f of x is equal to square root of x minus 4. And as you can see here, the function its domain starts at x equals 4 and goes on to infinity. And the range it starts at 0, and it's going to, because this function is always going to be going up, the range will be from 0 to infinity. In the next problem, number 6, it says to find the slope of the line containing given points. So again, I'm going to remind you, it's either change in y or change in x, where you can just stack the points and then just do subtraction. So the change in y is going to be 1, the change in x is going to be 5, and the slope would be 1/5. Or you can plot the points and draw the triangle. So you have 7, 6. So this would be 1, 2, 3, 4, 5, 6, 7. 6 would be here, 7, 6, and 2, 5. And you draw your triangle, and you see that this side is only equal to 1 because the change in y value is 1, and this side is equal to 5 because the change in the x value is 7 minus 2. So the slope is positive 1/5 from that perspective. Next question says find a linear function. Well, that's an equation of a line. So when they give you points that look like in function notation, you convert them to xy coordinates. So we have -5, -15, if I wrote that down correctly, and 4, 3, and we calculate first our slope. And remember what we did before, we take the difference in the y values. That would be -15 minus 3 and -5 minus 4. So the slope is going to equal 2. And then we use our points and we fill in the blanks on a point slope form. Oh, not point slope form, I'm sorry, slope intercept form. So I'm going to use the second point. I'm going to plug in the 3 here. I'm going to plug in my slope of 2. I'm going to plug in my x value of 4 and find what the b value is. So that would be 3 minus 8, and that would be -5. So my final equation is going to be 2x minus 5. And let me check. And there we go, 2x minus 5. In the next question, they have a humerus function. Well, it's not really that funny. It's actually the humerus, the bone. Bad play on words, I guess. But we have the humerus as a function of that's the elbow. That's the bone from the elbow to the shoulder is x centimeters long, and from that you can estimate the height of a woman whose humerus is 33.96 centimeters long. So we take the function who comes up with this stuff, right? But this is the function, and if we plug in the value of 33.96, and you can use your calculators for this, we get the humerus for the height of a woman based on the humerus size to be 164.87 centimeters. In the next application, a deep sea diving bell is lowered. This is basically a bell that holds divers, and it's going down to great depths in the ocean. And so what they have here is that they say after 8 minutes, the depth is at 300 feet. And after 40 minutes, the bell is at 1,600 feet. So basically, they're giving us an idea of time. So here we are at 8. We're at 300 feet. And then after 40 minutes, we're at 1,600 feet. So they want to know what the average rate of lowering per minute is. So that's basically a slope of this line. If you noticed on this triangle here, the distance that has transpired is 1,300 feet. So it's basically a slope calculation they want us to do, and the time that's allotted, or that's elapsed, is 32 minutes. So you can figure out the average rate at which the bell was lowering by taking 1,300 feet and dividing that by 32 minutes. And let me just pause while I calculate on the calculator. And that would be 40.625 feet per minute. So that would be choice B would be our best answer. On the next graph, they just want to know if this is a function or not. Well, all you have to do is examine if it passes the vertical line test, and it looks like everywhere you examine the function, it passes the vertical line test. On the next one, same thing. It wants you to check to see if it can be a function. And we're good up until here, and then when you cross through here, people might think, oh, it can't be a function. But, trick question, because that's an open circle, it doesn't really exist underneath that closed circle. So when you pass the vertical line through, it actually can be a function, because there's only one function value at that x location. So this is another yes. In the next problem, they want us to use our graphing calculator to graph the equation. So remember, when you use your graphing calculator in the standard viewing window, make sure your window is set up with these settings, and make sure you solve the equation y equals, you have to solve it for y, -4 minus 6x, or you'd have y equals -6x minus 4. Order of addition doesn't matter, so however you enter it in terms of those two functions is fine. And so you would end up getting a plot that is at -4, and it would look something like this, except the line would be much straighter. Okay, and you should always label next to it what the equation is, and we're moving on. Okay, this is probably a good point for me to process this video, and I'll probably have a second part of this video up for you later on today.